Hello. Now we're going to continue our work in algebra, and we are going to look at how we can form a quadratic equation if we know the roots of that equation. So you can see that I've drawn two graphs here, and we're going to start looking at the one on the top left. Again, these are basic sketches that are to help us get an intuition into the question, and this is a really important skill to develop for a lot of higher level maths. So I have a basic sketch drawn of my quadratic based on my y-intercept. I know that when I'm crossing the y-axis, I should have y written in here. When I'm crossing the y-axis, I know my x values are 0, so my y is just going to be given to me by the constant on the end, because anything involving x when I'm crossing the y-axis is going to be 0. So I know that this function crosses the y-axis at -3. This is a key point for being able to read equations. And I know that if I want to find two other points on my graph, I can set y equal to 0 and solve the quadratic to get values of x for where I am crossing the x-axis, for when y is 0. So this we're already familiar with. We can do it very well. But say we have the opposite situation. Say I am given x is equal to 3, x is equal to -1, and I'm told these are the roots of a quadratic. Form the quadratic. I could also be told that we have the points 3, 0 and -1, 0, and form a quadratic from them. This is the same thing, because I know that my y values being 0 means I'm dealing with my roots. So if I have to form a quadratic from these, the way that we do it is to simply follow these steps exactly backwards. There's no difference in it at all. If we start out with a quadratic, we can factorize it down and get roots. If we start with roots, we can go in exactly the opposite direction and end up with a quadratic. So let's do that. Well, what was my steps here? I had my quadratic, I factorized it into two brackets, and then I set each bracket individually equal to 0 and solved for x. Well, now I've got the solved for x part, so I'm going to do that in reverse. So I want to rearrange this into the form where I have everything equals 0. So I'm going to subtract 3 from both sides to get equals 0 on the right hand side, and plus 1 here, plus 1 here. So my two equations become x minus 3 is equal to 0, and x plus 1 is equal to 0. Now, if I'm thinking about that I'm doing this backwards, this is a factor, and this is a factor of my quadratic. So I know if I multiply my two factors together, I must get the quadratic. Multiplying out my brackets, I'll get x squared plus x minus 3, x minus 3. Adding up like terms, I get x squared minus 2x minus 3 is equal to 0. Lo and behold, it is the quadratic that I started out with. So that's worked perfectly. But there's a hitch, and you might have seen it based on the graph that I've drawn here. This quadratic has exactly the same roots as the quadratic I started out with. So we actually have to be a little bit more careful than this question might indicate. These steps are the steps we're going to have to follow, but we have to take into account that we might be dealing with some multiple of the roots. We could have ended up multiplying, in this case, our factors by 2. So if you look at the connection between these two quadratics, this quadratic here has been doubled. I have multiplied all of my terms by 2, but it hasn't affected the roots at all. So I need to know more information than just the roots in order to form an exact quadratic equation. I also need to know a point on the curve, and usually I'll look for the y-intercept because it makes the maths fairly easy. But we're going to come to that in a minute. First of all, I just want to go down through factorizing this and show that we get exactly the same roots. So if I want to factorize this, I'm going to take my two terms on the end and multiply them out, and I get my -12. I write out all of the factors that can work out to minus 12. And I know that I can do this with my minus b formula as well, and I get full marks for using my minus b formula. There is no issue ever with using the minus b formula if you feel more comfortable with it. We look for what factors add together to give the number in front of my x, and multiply together to give the number on the end, or sorry, to give the number minus 12. And the one that works out in this case is 2 and minus 6. Plus 2 minus 6 would give me minus 4. So I end up with 2x squared plus 2x minus 6x minus 6 is equal to 0. Take out what's common to the first two and the second two. 2x is common, and I end up with x plus 1. Minus 6 is common, and I end up with x plus 1. So I end up with x plus 1 multiplied by 2x minus 6 is equal to 0. Now we're always looking for common factors, so you don't actually need to do the next part, but I'm just going to point out to you that if you could take out, this could be rewritten as 2 times, there's a common factor of 2 here, so it could be 2 times x minus 3 on x plus 1 is equal to 0. And it doesn't matter that we're multiplying by 2. This could be equal to 0, or this could be equal to 0. So we could still break it up into x minus 3 equals 0, and x plus 1 equals 0. And we solve that, and x is equal to 3, and x is equal to minus 1. So we end up with the same roots again. This line here I have written to highlight how it is that we're going to solve this problem of we could be dealing with any multiple of our roots of our original factors. So what we're going to do is find out what number we are multiplying by here. So I'm going to write out what we need to keep in mind, and then I'm going to do an example starting with roots and then building up to a definite quadratic equation. Now, we're going to talk through this, and this is just our general guidelines based on our discussion. So we need the roots and the point on the curve. So we can see why the roots by themselves are not enough. We would need to know a point on the curve as well, usually the y-intercept, so that we can definitely get the right quadratic equation. Otherwise, we don't know whether it would be 2x squared minus 4x minus 6, or it could be x squared minus 2x minus 3. Both of these have exactly the same roots. It's just that the bottom one is multiplied by 2. And without a point on the line, other than our roots, we don't know what equation we're talking about. Now, sometimes you can be asked to form a quadratic equation given roots. So as opposed to a specific one, you could just be asked to form a quadratic equation, in which case you just do what we did here. You just multiply, you find the factors from the roots and then multiply out as we did in our middle example here. If they ask you for a quadratic without further information, that's what they mean for you to do. If they give you more information about where it crosses the y-axis, or if they give you a point on the curve, we have to take that into account and use it to get a specific quadratic equation. Now, let's put this into practice. I'm given 2 roots, and I'm told that my y-intercept is at x is minus 2. So let's go through our stages. I need to form the factors given my roots. And I know from having done lots of factorizing that that just means I'm going to get my roots equal to 0. So to that end, I am going to multiply both sides by 4. You can do this question keeping fractions involved, but it is generally neater and nicer if we turn everything, if we get rid of fractions. This is a very true general rule in our equations. Fractions are generally a nuisance. So 4x minus 1 is equal to 0. This is one of my factors. And then I want to rearrange this one to make it equal to 0, so I'm adding 1 to both sides, and x plus 1 is equal to 0. This is another one of my factors. So if I was doing this naively, or if I was just asked to find a quadratic, I'd just multiply these two factors together. But because I'm given this information, sometimes in a graph, like I did here, or sometimes given as straight information like this, I'm going to need to take that into account. So I could have just 4x minus 1 multiplied by x plus 1. They could be the whole story, but there could also be some multiple of them. I could be multiplying by some number, which I'm going to call k. So what I want to do is multiply that out, and this is going to help me to find my quadratic. So my quadratic is going to be y is equal to my quadratic. K is just some number, like k would have been 2 in this case, because I was multiplying my original quadratic, my original factors multiplied together, by 2. So what we're going to do is multiply out the bracket and then see how we can use k to finish our problem. K sitting on the outside, I'm going to draw a big square bracket and do my multiplying out here. So I end up with 4k squared plus 4x, I should say, minus x minus 1. The square brackets are optional. It's just that if we have lots of stuff going on inside, so I use a bigger looking bracket. So I get 4x squared plus 3x minus 1. Now, can we see our problem? So this is our quadratic. Can we see our problem? What is the y-intercept of this quadratic here, the quadratic that is in brackets? The y-intercept of this quadratic would be minus 1. But I'm told that this quadratic has a y-intercept, it crosses the y-axis, at minus 2. Now immediately that tells me that k is going to be 2. But if it was a more complicated situation, I would do a substitution. I know that the point x is 0, y is minus 2 is on my line. So let's just do that substitution. I know that 0 minus 2 is on my line, so let's just sub that in. So y is minus 2 is equal to k on 4 by 0 squared plus 3 on 0 minus 1, close bracket, minus 2 is equal to k on minus 1 is equal to minus k. Therefore, k is equal to 2. So my quadratic then would be y is equal to 2 on 4x squared plus 3x minus 1 is equal to 8x squared plus 6x minus 2. So this the beginning of this, where we can see that we're just doing our factorizing in reverse to get back to our quadratic, is very straightforward. And hopefully we're happy that the only fly in the ointment, the only extra bit that we can get, is that we might have actually multiplied our quadratic by some constant, by some number. And the way that we would check that is by looking for either the y-intercept or any other point on the line that isn't the roots. And that will allow us, by writing it out like this and then subbing in the point that we know on the line, that will allow us to find the value of k and therefore get the definitive quadratic that we are talking about. And that is what we need for forming quadratics from given roots.